The greatest animal on land, the African elephant. These beauties have moved from the African savanna to Southern California to teach us about their biology. This knowledge is being used to help save wild elephants. What we learn here at Elephant Valley might change how we see elephants forever. This is the elephant of the future.
Hi, I'm Danielle Dufault, and you're watching Animalogic.
When thinking of elephant research, sunny Southern California might not be the first place that comes to mind. But deep within its picturesque landscapes, there's a place that's leading the pack when it comes to elephant welfare. This is the San Diego Safari Park. Recently, we had the chance to visit and get up close with their elephants and the people who care for them, and the scientists who are using the latest technological tools to learn about elephants and use that knowledge to support conservation efforts. But before we really get into it, let's start with why they're doing it. Elephants are some of the smartest, cutest, and most charismatic animals in the world. They're the largest land animals on Earth and have been part of human life since its beginnings. It's high praise, and it's not even a little bit surprising to hear about how amazing elephants are. Elephants are quite simply undeniable, and they're not only important to us, but also to all animals in their ecosystem. Elephants maintain savannas by breaking down branches, thorny bushes, and old trees. This keeps the grasslands from getting overgrown. This keeps the land optimal for grazing animals, which in turn helps the predators that rely on those herbivores to survive. When they dig for water, they create watering holes that are used by other animals. And as they walk vast distances, they spread seeds through their nutrient-rich dung. Their dung is processed by animals like dung beetles, which spread it out even further and fertilize the soil. At a social level, they live in complex matriarchies with a leader in charge of navigating the savanna, finding food, and leading migrations. They communicate with each other through a combination of sounds, low-frequency rumblings, and body language. When a member of the herd dies, the other members seem to grieve and spend time around the remains of their deceased relative and comfort each other. But unfortunately, we humans haven't been as great to elephants as they deserve. Growing human populations have led to increased farmland usage and conflict with elephants. Elephants sometimes walk over the farms while on their migrations in search of food and water. This makes the farmers retaliate. At the same time, the construction of communities, fences, and roads is fragmenting elephant habitats. This makes it harder for them to make their migrations and access food and water, and by splitting up populations, it weakens their genetic diversity. The illegal wildlife trade continues to be a problem in large parts of their range. And finally, climate change is causing longer droughts, changing rainfall patterns, and making elephants compete with humans for ever-shrinking pockets of vegetation in Africa. Because of all of these issues, elephants are now an endangered species. Okay, so what do we do about it? It's a big question, and big questions don't have one simple answer, but a number of complex, complementary answers. We're here at Elephant Valley to find some of those answers. One of the biggest hurdles in conservation is making people care about wildlife. People protect what they love, and getting the chance to see animals up close is one of the most direct ways of falling in love with them. Many researchers and animal lovers like myself caught our first glimpse of real-life African wildlife in places like this. And for many of us, that sense of awe and wonder remains today, as fresh as it was that distant afternoon our parents took us to discover elephants. Thanks, Mom and Dad.
I'm just watching this elephant feed itself and all of its movements and whatnot. It's just really interesting to see how flexible that trunk really is. Oh my gosh, do you see that?
They're still amazing even after 20 years. This is the important part. Data alone doesn't change behavior, so the goal is that visitors will see these elephants and feel empathy, and that empathy turns into conservation action. But of course, it has to be good for the elephants too. We've all seen pictures of animals in not so great conditions at zoos around the world. But I think that's what sets Elephant Valley apart. The habitat is meant to look and feel like the African savanna. The plants are the same they would encounter in the wild. The trees make elephants walk around them to get to the watering holes and food sources. And the elevated feeders entertain elephants while they eat. And the fun thing is that everything is edible. All the berries and leaves are nutritious to elephants, so elephants can have fun exploring different types of snacks. And even though the habitat is huge, you can see them from up close from pretty much anywhere. You can see both their humongous biology and their complex social dynamics. This is where the second answer to the question, what to do about elephant conservation, comes in. Elephant Valley is connected to the San Diego Zoo Wildlife Alliance, the research arm of the organization. A surprising amount of research takes place here. Researchers get access to elephants and can monitor all sorts of data, from feeding patterns to growth rates, to health markers in blood, to the social drama elephants are constantly embroiled in. This, of course, is a huge advantage over studying wild animals that move around huge areas of land and can't be monitored as closely. A key part of the research is that the elephants are willing participants. Trainers build a trust with them, but they can leave at any time. Elephants aren't above a little bribery, and some delicious, healthy snacks bring all the boys to the yard. And by boys, I do mean girls. We're going to show you how some of the training and experiments done here take place. We got exclusive access to see how the team gets all their data.
So right now, they're calling the elephants over because it's time for a session. And they do know their names. So it's Mgani and Makaya, mother and a daughter.
Daddy,
These are going to be the first ones we see. Oh, she's coming.
So here comes Makaya. She's
Makaya?
always very excited for a training session. And then
Oh, look at
Mgani's
her.
coming
She's
right behind her.
beautiful.
Mgani is beautiful. She is kind of our supermodel mom here at the safari park. She's got those
Oh,
nice
wow.
long tusks.
Part of the work is teaching the elephants to have fun cooperating when they're getting their checkups.
This is a mouth open. So this is a great behavior to see the health of their teeth, their tongue. If we need to give medication, we train them to swallow pills. Yeah, so we can do a turn and we can check their tail. You can put a blood pressure cuff on their tail. We can take measurements of the tail. You can do a ton of different behaviors. This is a lean in that they're both doing now. So from a lean in, we can see their ears.
Okay.
You can see those very large veins.
Oh, yes.
Yeah.
Wow.
So the veins can be about the diameter of your thumb, and that's where we can draw blood voluntarily from these elephants. So Makaya gets a blood sample every other week. We have participated in EEHV studies.
Look at those blood
Yeah.
vessels.
So we can measure anything, basically. So when these calves were born, we really took a ton of data, everything. When their first tusk erupted, how long the
yeah.
tusks are at a certain age, the first time they're eating solid food. So really just collecting as much data as we can to answer, unanswered questions about elephant. They just did a milk sample on her.
Oh, no
Collected
way.
some milk.
We have
Little bit.
elephant milk.
Yeah, so she's still nursing, even at 7 years old.
That's kind of shocking to me. I've never heard of
Yeah.
how long elephants nurse for.
Yeah.
But 7 years, that's a long time.
7 years is a pretty long time. They can go 4 to 6 years, but the team can collect milk voluntarily anytime.
That's amazing.
Have you ever seen an elephant nurse? I was shocked to find out how they do it.
There's the mammary gland there, how they
Ah.
can take milk.
Oh, those are very forward.
It's, right under the
Yes.
arms. You wouldn't think that. You would think like udders like a cow, but
So their milk line starts up there and goes all the way down?
no, it's just the 2 mammaries under the armpits.
2 mammaries?
Yep, just 2 mammaries.
Okay.
Yep.
And how would you guess they study the inside of their trunks?
So this is a practice trunk wash. In the trunk, we'll pour saline,
Okay.
and then we'll raise their trunk up so the saline flushes down the trunk, and then they'll blow it into a bag. So we can do that to test for a variety of different things.
One of the coolest technologies they're studying is using drones to gauge the physical conditions of elephants, both in human care and in the wild.
Here we're going to be measuring the height of the elephants, the length of the elephants. We also have drones here at the safari park that we can use, and so they can use drone footage out in the wild to look at an elephant from up above and maybe be able to see what the body mass index of that elephant is, the health of that elephant, that we can then compare with our elephants here with the known knowledge that we have here.
Studying social groups here can help conservationists and park rangers manage wild herds in Africa. Understanding how different diets, degrees of stress, and levels of activity affect the elephant's health can be applied to support elephants in the wild and under human care. All of their findings are shared with conservation groups like Save the Elephants, the Kenya Wildlife Service, and the Northern Rangelands Trust, which means that all of this research is not done just out of our scientific curiosity, but with the specific goal of helping elephants in the wild. And likewise, those organizations share their knowledge with the San Diego Zoo Wildlife Alliance to improve the quality of life of the elephants here. The long-term success of any conservation initiative depends on engaging the local communities, helping them tear down some of the barriers they have for conservation, and preventing conflict with wildlife. Some of the ways that this is being done is by creating wildlife corridors for elephants and establishing
San Diego Safari Park for accommodating us here, showing us their work with the elephants, and really just bringing us in close to the magic that this species really is.
Squids are the largest invertebrates in the world. There are hundreds of millions of them in the ocean, and yet we almost never see them. But why? What evolutionary tools do they have that make them so successful? And how have they managed to avoid us for thousands of years? These are the enigmatic giant squids. The kraken, the sea monk, the great sea serpent, and the great calamari are some of the names given to these enormous ocean creatures. We've been talking about these creatures for as long as sailors have been exploring the oceans. And yet for the vast majority of human existence, nobody had ever seen one alive. Because we didn't know any better, we assumed them to be monsters, and gave them fantastical names like the Scylla in Greek mythology, the Lusca of the Caribbean, and of course, the Kraken of Norse mythology. Before modern times, all we had was mariners' tales and dead specimens found in the stomachs of whales or washed ashore on the beach. Most of the giant decapods found in Europe were likely Architeuthis dux, which is simply known as the giant squid. But there are 2 other enormous species that we should mention whenever we talk about the largest invertebrates in the world: the colossal squid and the bigfin squid. But let's focus on the one that's fascinated seamen and beachgoers all over the world for millennia: the giant squid. Giant squids are absolutely massive. If you include the length of their tentacles, they can be up to 12 meters long and weigh over 250 kilograms. Their eyes, along with those of the colossal squid, are the largest in the animal kingdom at just under 30 centimeters in diameter. For context, a swordfish, which weighs the same as the giant squid and lives in similar habitats, has eyes about 10 centimeters wide in diameter, and human eyes are 2.4 centimeters wide on average. That is just way too much squid. A large female can be twice as long as a great white shark, and likely larger than a megalodon ever got. They're also full-time carnivores, so there's no need to look for monsters in mythology books. Giants still roam the earth and the sea. and they roam a huge part of the world, having been found in temperate waters from Russia to Tasmania. They seem to not love the tropical seas, but they have been spotted in vacation hotspots like Florida and Hawaii. Wherever they go, they're always looking for their next meal. Giant squid catch their meals with 2 enormous tentacles, which can be up to 7 meters long, easily big enough to wrap them around ancient medieval fishing boats, which is where the legends probably come from. The tentacles are lined with dozens of hard, serrated suction cups controlled by muscles beneath them. These suckers dig into the prey's flesh and apply suction forces of up to 100 pounds per square inch. So in theory, they only need a couple of suckers to lift you. That's more than enough force to secure and hold their prey in place, while the squid rips it apart with its giant parrot-like beak. Their beak is bigger than your fist, and is only the first step of their meat processing operation. Inside their mouth, they have rasps that work as flesh graters. Once a living being goes in there, the V-shaped stream of light across the closing beak is the last thing it sees. These hunting tools also work as their only self-defense against their main predators, whales. But how do noodly appendages and an oversized parrot beak translate to battle with some of the largest animals to ever live? Well, not great. Even more than the beaches where they sometimes wash ashore, the stomach of a sperm whale is the most likely place you'll ever find a giant squid. These whales often have scars from the giant squid suckers. Their skin bears the marks of countless battles with these massive cephalopods. But size is usually the deciding factor, and whales are the ocean's heavyweight champions. Sperm whales are so whale adapted to eating giant squids that their intestines produce a wax called ambergris to wrap squid beaks and protect their organs as these biological shears go through their digestive system. These waxy substances have a pungent, salty smell. They smell like they came out of a whale's butt. And yet, they're used in the perfume industry, and large blocks of it can go for over $1 million. And of course, because of this, there are professional ambergris hunters, in case you're thinking of a career change. So many giant squids are found inside sperm whale bellies. Scientists estimate that these marine mammals eat up to 100 million of them a year. These remains have provided scientists with most of the information we know about giant squids. The rest come from the beached squids, but these animals rot very quickly, and by the time they land on a beach, they've likely already been dead for a few days. So weirdly, the partially digested remains inside whales' stomachs are often more complete. There's also the live squids that people have been reporting for centuries. Giant squids maintain buoyancy through ammonium chloride in their system, and when they die, they float up to the surface, unlike most cephalopods. And this chemical also makes them taste like salty licorice, which is pretty gnarly. Sometimes, giant squids float up before they die, usually when they're very old, sick, or injured. And often, in this disoriented state, is when they reach their tentacles into boats. It's a very small window before it dies and rots, but it tracks with how giant squids live their life. They reach sexual maturity at just about 3 years of age, and have a life expectancy of just 5 years. That's it! They get that big in just 5 years. For comparison's sake, great white sharks become sexually mature at 20 years of age and live as long as an average human being. On top of that, females have been found with over 1 million eggs yet to be released. So they reproduce young and at a massive scale. This short generation length helps them adapt quickly to environmental changes and replenish populations year after year. And yet, despite their huge numbers, we almost never see them. This started changing at the start of the century. In 2002, the first picture of a confirmed live giant squid was taken in Japan. The cephalopod had gotten stranded on a shallow bay. The locals tried to secure it, but it died the next day. 2 years later, a baited camera caught a glimpse of a giant squid using its tentacles to grasp the bait ball. Since then, improvements in camera technology and an increased accessibility to submarines has led to videos like these. This was taken by NOAA in 2019. From a wall of darkness, you see a bouquet of arms approaching the camera. The squid examines it with its tentacles, and after realizing there's not much food to be had, it disappears into the bottom of the ocean. Videos keep popping up every once in a while, showing us the power and majesty of giant squids. But, mighty as they are, they only play second fiddle to the colossal squid. Colossal squids can be up to 700 kilograms, over twice as big as a giant squid. Even though their tentacles aren't as long as the giant squids, their eyes are slightly larger. In theory, they should be as famous as their cousins, but two reasons work against their popularity. They only live around Antarctica, and they seem to live at even deeper levels than the giant squid. Lastly, we have the big fin squid. In a family of alien-looking creatures, these are the weirdos of the bunch. And I know that's saying a lot. They're slightly smaller than the other two leviathans we mentioned earlier, but still get to lengths of up to 8 meters. They're so ghostly and ethereal that they only weigh 2 kilograms. Their arms seem to bend at elbows into noodle-like appendages that drift behind the animal. They've only been seen a couple of times, but one of them gave us one of the greatest squid observations of all time. In 2019, NOAA filmed one alive. It was about 3.5 meters long, and it was 750 meters deep. You can see its long arms, see-through mantle, and giant eyes. And despite its size, it looked so fragile and tender.
Oh gosh. Oh, look how cool.
No, it's just so...
It's a big fin squid, maybe?
It's ghostly.
Magna Pina?
Magna Pina?
Oh man, look at him.
And there you have it, the fantastic world of giant squids. And the coolest thing is that we keep learning more and more about them. Next time we make a video about these gigantic creatures, there will be a whole new batch of discoveries about them. When we think of the biggest creatures that have ever lived, our minds might wander to the dinosaurs of yore. Diplodocus with its neck reaching up into the sky. Tyrannosaurus rex, that enormous and terrible lizard king. And the longest of them all, Patagotitan, which was about the size of 4 school buses parked end to end. But what if I was to tell you that the largest known animal to ever exist lives among us? They are here and now, swimming around the depths of our vast oceans. This is the blue whale.
The blue whale is not just the largest mammal on Earth. It's very likely the largest animal to ever exist. Ever. No dinos or sea creatures from the past can compare. At least, not that we know of. And if there were, we probably would have found fossils by now. So how big are these blue cuties? Let's try our best to fully comprehend just how big a blue whale can be.
A blue whale is an incredibly long animal. The largest examples of blue whales are over 30 meters long. That's 20 average-sized humans laying end to end.
Next time you're at your family reunion, recruit your parents, your grandparents, your weird uncle, your kooky aunt, and your 2 favorite cousins to lay in a line. Then you simply have to ask 10 more members of your extended family to lay down too. Only now can you truly appreciate how long a blue whale is.
But their length isn't even the most impressive thing about blue whales when it comes to their sheer size. One of the largest ever found weighed over 190,000 kilograms.
Sticking with the family reunion metaphor, that's the equivalent of all the family you just asked to lay on the ground, plus another 2,480 people. To put that into perspective, that's the weight of you, your parents, your 4 grandparents, your 8 great-grandparents, your 16 great-great-grandparents, your 32 great-great-great-grandparents, your 64 great-great-great-great-grandparents, your 128 great-great-great-great-great-grandparents, your 256 great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great great-great-great-great-great-grandparents, your 512 great-great-great-great-great-great-great-grandparents, and your 1024 great-great-great-great-great-great-great-grandparents. That's like every direct relative you've had since the year 1700, plus another 450 people. This blue human group would equal just a single blue whale.
The scale of these creatures is really quite dizzying. The flippers, for example, are around 3 meters long, or about the length of an SUV. While this is certainly enormous, the blue whale's flippers are considered small because they only represent about 12% of their body length. The longest flippers relative to body length in cetaceans goes to the humpback whale, which sports flippers that are a third of their overall body length.
While we're on flippers, did you know that flippers are essentially just modified hands? If you were to x-ray a flipper, you would see the distinctive bones that make up these appendages. But let's keep going with our body scan of the big blue.
The eyes of the blue whale are about the size of a mini soccer ball. Compare that to our eyeballs, which are slightly smaller than a golf ball. Although the blue whale is the biggest creature on Earth, it doesn't have the biggest eyeballs either. That honor goes to the giant squid, which has peepers the size of a basketball. They need those humongous eyes in order to see in extremely low light conditions of the deep sea. But the blue whale makes do with a relatively smaller eye by foraging closer to the surface and singing songs to communicate with each other.
It would be incredible to see them in person. And who knows, maybe one day we will. There is so much lore surrounding the size of blue whales, including that you could park a Volkswagen Beetle in a blue whale's heart and swim through its arteries. Let's examine that whale of a tail.
While not the size of a compact car, the heart of the blue whale is still about 180 kilograms and 1.5 meters tall. That's about the size of 640 human hearts. While their arteries are large, they definitely aren't big enough to swim through. You could definitely send a volleyball through one of them with room to spare, though. Or if you're, say, an Olympic gymnast, you might be able to squeeze through the largest arteries.
Just as expected from an animal of their size, these huge mammals are also capable of producing the loudest sounds of any animal. They are as loud as a jet engine.
Blue whales don't have vocal cords like we do. Instead, their U-shaped voice box presses up against a specialized cushion of fat and muscle to produce these extremely loud sounds that can be heard up to thousands of kilometers away. Some of the sounds they produce, called infrasonic sounds, are so low that we humans aren't even capable of hearing them. But if we were close enough, we would certainly feel the vibrations in our bellies.
With anatomy this large, you would think that everything on a blue whale would be enormous. But one part is actually surprisingly small. I am, of course, talking about its throat.
The throat of a blue whale is actually only 10 to 20 centimeters wide. To compare, a human throat is about 2 centimeters wide, meaning that it's not even 10 times larger than a human's, despite the entire animal itself being 2,500 times heavier. The reason their throat is so small is simple. It's because these whales have adapted to eat very small prey.
Blue whales are what are called baleen whales, meaning that they have baleen plates, mustache-looking structures made of the same substance that our hair is made of, that filters out the tiny krill that they eat. It seems unlikely that the largest animal would eat one of the smallest, but when there's a krill, there's a whale.
To feed, the blue whale will charge at a group of krill, opening its massive jaws. The pleats on the underside of its lower jaw allow it to take in up to 70 tons of water and krill in a single mouthful.
The whale will then press its tongue upwards to the roof of its mouth, forcing the water out, with their baleen plates keeping the krill in. The only thing left to do is swallow the krill, which presents no problem because the 1 to 2 centimeter krill go right down that 10 to 20 centimeter hatch. It's kinda like when kids at the pool spit water through their teeth. Only in their case, they're keeping millions of prey animals in their cavernous mouths.
It takes a lot of krill to power a body of that size, with blue whales eating upwards of 14,500 kilograms daily. That's like eating the equivalent weight of 3 elephants every single day.
Considering that blue whales are estimated to live 80 to 90 years, that's like eating close to 100,000 elephants worth of krill in a lifetime. But with around 700 trillion Antarctic krill, weighing about 400 million tons swimming around at any given time in the Southern Ocean alone, at least we know their food is in good supply. For now, at least.
For comparison, that's about how much all the humans on Earth weigh too.
Keeping krill in good supply is, as you can imagine, krilltical. We talked to our friend Diane, who's been studying blue whales in the Gulf of California for over 30 years, to learn more.
The whales are very good gardener of their own ecosystem. So the whales feed down below the photic zone, where the phytoplankton is, and then it defecate at surface. And we also did experiments with the feces, looking at, in 3 different big bottles at sea, close to where the whales are, without just the normal water with the phytoplankton there, same water with a little bit of feces, and the same water with double of feces. And the productivity after the first bottle, after a couple of days, went down. There was not enough nutrient, the phytoplankton just went down. In the second bottle, it went up after 3 days, and the other one went way up. So what happened is that in the feces, there's a lot of nutriment. They spend 1.5 months in the same place. They're not going and coming, and they stay there. And so if they stay there 1.5 months, 2 months, maybe what they do by feeding and defecating enhance so they can continue to feed.
In other words, whales eat krill in deep water. Then they poop at the surface. Bacteria turn the feces into food for microscopic plants, and their numbers explode. The plants feed krill, and they also multiply. And then the whale eats the krill. So the whales actively make the surface more productive by bringing nutrients from the bottom of the ocean to the surface. But eventually, it's time to move on. So where did these whales go? To find out, we asked our friend Dr. John Ryan, who listens to blue whale songs to track their numbers.
Blue whales, they just simply have to search farther and wider to find the krill. We can hear when they migrate, so they change, but that's because they change how they sing. So we can hear when they're migrating, and therefore we can listen and know how that migration changes from year to year. And that's where we learned that blue whales will change the timing of their migration by up to 1/3 of the year, which is the full length of a migration period sometimes. And that's because they have to adapt. They have to always take advantage of when an ecosystem allows them to pack on energy stores.
So if there's food, they'll stick around. But if not, they'll go look for it elsewhere. It sounds simple at first, until you start wondering how the heck whales find krill in the vastness of the ocean.
In an environment where the physical features defined by different water masses can be very small scale, the whales are finding them persistently and consistently with precision that is just mind-blowing. And what's important about that is that's the only way they can survive. If they can't navigate a complex environment that's changing continuously and find those dense krill swarms, they won't persist as a species, because they need to consume so much food every day just to sustain that massive body. So the precision of a giant has blown my mind.
Another problem blue whales face is that, like everyone, they have some very annoying relatives.
Another day, it was that whale that was accompanied by Tursiops, bottlenose dolphin. And at the beginning, we found, oh, that's cool, because the dolphin, when they follow the whales, they come at surface before the whale, so it's easy to follow the whale, let's say, so especially if it's traveling. And that whale was kind of traveling, it was not making circle or anything. But these dolphins there was a group of maybe 25. They followed that whale the whole day. The whale was so upset. You have no idea. She really tried. It was a male, actually. He really tried to get away, but there was no point. I mean, they were always on her head, on his head. And I felt that nobody has ever reported that maybe it would make. But like the frigate bird that follow gulls or other birds, so they regurgitate and they steal the fish they have. I had the feeling that these dolphins wanted that whale to regurgitate. It's crazy.
Who knew dolphins were that into krill tartare? And the worst part is that blue whales evolved from toothed whales, similar to dolphins. We know this from the fossil record, but what is harder to determine is just when these baleen structures started evolving. Unlike teeth, which are made of bone, baleen are more akin to hair or fingernails, meaning that they don't fossilize as well.
Regardless of when it occurred, it's the evolution of the baleen that seems to be the key to becoming so massive.
According to a recent paper, researchers used advanced trackers attached to the whales, analyzing over 10,000 feeding events of both toothed and baleen whales. They discovered that the cap for size for toothed whales is about the size of a sperm whale, because of the trade-off between calories it takes to hunt and the calories gained from eating the krill.
Baleen whales, like blue whales on the flip side, can take in as much as 10 million calories in a single enormous gulp, meaning that they can expend a lot less energy to intake nutrition, thereby allowing them to grow to such epic proportions.
But becoming so humongous is actually pretty recent for whales, at least in evolutionary terms, happening in the last few million years. And it all seems to be linked to the ice ages. As nutrients run off in times of melt, prey for baleen whales became super abundant. It's the same reason these whales today still travel long distances to their summer feeding grounds in polar climates. And it's these oscillations in food availability caused by the ice ages that are likely limiting them from becoming even larger.
Getting that large for a whale is kind of cheating anyway. Let me explain.
Animals that live exclusively in water have an easier time of existing as behemoths, since their every movement and ounce of mass doesn't need to fight against gravity. Whales in general lack the skeletal and muscular structure to hold their shape outside of water.
This is part of the reason why beached whales are doomed to die.
In addition to dehydration and overheating, just like a human lost in the desert, stranded whales will suffer what are called crush injuries. Crush injuries are just what they sound like, injuries sustained by a massive cetacean's organs being crushed internally by its own weight on land.
Even if humans manage to intervene and get the whale back into the water, they can die a few hours later anyway as a result of these crush injuries.
That's because being back in the water with the pressure off releases toxic products from their crushed organs into the whale's body. All that to say, it is only because they grow and evolve in an environment in which gravity has little effect are they free to balloon to sizes that would be difficult or even impossible to reach or maintain on land. So when we think all the way back to the biggest dinosaurs that ever lived, like Patagotitan, it actually makes the enormous feat of growing so enormous on land even more impressive.
It stands to reason that if you're the biggest around, your babies are going to be the biggest around too. Blue whale newborns win the award for chunkiest babies on Earth. Once out of the womb, like all mammals, they rely on mama's milk to stay chubby.
Blue whale babies will drink around 200 liters of their mama's extra fatty milk per day. While human milk is around 4% fat, the milk of the blue whale is about 50% fat to help the babies bulk up and gain 200 pounds a day. The thick, fatty consistency here is key for underwater feeding, since blue whale babies don't suckle like other mammals. Instead, the mama whale releases milk in a stream that the baby can drink without also chugging too much seawater.
Some of the research we've been most excited to learn about is whale tagging, which is basically a GoPro with extra sensors and a GPS tracker. Thanks to the work of groups like Cascadia Research, we get to know where they go, what they do, who they hang out with, and how long they stay out at night. We're finally getting to see life from a whale's point of view. That data will help us understand them better and protect them more efficiently. We're also getting better at slowing down for whales. There are amazing initiatives, like Blue Whales, Blue Skies, that work with shipping companies to move at a speed safe for whales, to give them time to dive out of the way.
Vessel strikes and entanglement in commercial fishing nets are a big problem. But pollution, habitat degradation, climate change, and even ocean noise can severely negatively impact these wonders of nature.
Thankfully, organizations like Blue Whales, Blue Skies, Cascadia Research, Diane and her team, NOAA Fisheries, the International Whaling Commission, the World Wildlife Federation, Whale and Dolphin Conservation, Save the Whales, the Blue Whale Project, and the Pacific Whale Foundation, and many others are stepping in to protect these whales and their habitats.
If we act now, we can save these amazing creatures from becoming just more gigantic bones in our museums. But for now, if you can, support conservation organizations, sustainable ecotourism, and tell everyone about how lucky we are to live at the same time as the literally greatest animal to ever exist.
It's a bird! It's a plane! No, wait, it's not flying at all. Or was it? I dare you to say that to my face. If you thought that escalated quickly, you don't know anything about the wild world of paleontology. Today, we're uncovering one of paleontology's hottest debates. Could Quetzalcoatlus, the biggest winged giant in the history of our planet, actually fly?
If you know anything about paleontology, you'll know it's basically a blood sport. While you might be expecting mild-mannered researchers quietly examining dusty fossils, paleontologists are actually the scrappiest scientists of them all. And they have a history of starting epic, decades-long rivalries over long-dead creatures.
Like the infamous Bone Wars of the late 1800s, during which Othniel Charles Marsh and Edward Drinker Cope engaged in a bitter arms race to describe the greatest number of fossils. While it left them both penniless and disgraced, their contributions to paleontology were significant.
So asking a question like, could Quetzalcoatlus really fly, is also asking for trouble. You're opening a paleontological can of worms, and maybe even a can of whoop-ass. But let's start from the beginning. What is a Quetzalcoatlus, and why is it so controversial?
The debate of Quetzalcoatlus's ability to fly begins, of course, with its discovery back in the mid-1970s by paleontologist Douglas A. Lawson. His article, Pterosaur from the Latest Cretaceous of West Texas, Discovery of the Largest Flying Creature, published in the American Association for the Advancement of Science, has his thoughts on that question right there in the title, Flying Creature.
At the time of publication, and after 3 years of study, there was clearly no doubt in Lawson's mind that this giant pterosaur was capable of flight. Lawson, who was just a 22-year-old graduate student at the University of Texas at the time, has since become synonymous with Quetzalcoatlus, figuratively and quite literally. Despite referring to his initial discovery as just a large pterosaur in that initial publication, it wasn't long before he named the larger species Quetzalcoatlus northropi, and another, smaller species, Quetzalcoatlus lawsoni, was named after him.
The name of the genus was a reference to Quetzalcoatl, a feathered serpent in Aztec mythology. The nod to the Aztecs was due to the location of the fossils. Lawson made his discoveries in Big Bend National Park, West Texas, which is known as one of the world's true jewels of paleontology. With a geology spanning about 500 million years, it's not just famous for producing the first Quetzalcoatlus fossils, it's also one of the few sites in the world that records the Cretaceous-Paleogene boundary.
This is the thin layer of rock that recorded the moment in time 66 million years ago when a 10 to 15 kilometer wide asteroid smacked into the Earth and killed most of the large creatures on Earth.
The first Quetzalcoatlus was found 1.5 meters below the boundary, meaning it lived between 66 and 68 million years ago. Not only is it the largest pterosaur we've ever found, it was also one of the last to exist before that fateful end of the Age of Reptiles.
The trouble with Lawson's discovery was that there were only a handful of specimens found from 3 individuals. Some wing, neck, hind limb, and jaw bones were all that Lawson had to go on.
The location of the fossils seemed to indicate a carrion-eating creature due to their cervical structures, and since they were found close to sauropod fossils. But the discovery of these Quetzalcoatlus fossils left more open questions than answers, some that even persist to this day.
Pterosaurs were the first vertebrates to evolve powered flight, which means they could produce lift and stay airborne. In other words, they weren't just gliders, they were full-blown flappers.
Important side note, despite their similarities, birds did not evolve from pterosaurs. Birds evolved from dinosaurs, which share a common ancestor with pterosaurs, but were not closely related. These similarities are an example of convergent evolution, which means that 2 unrelated species developed similar characteristics.
Convergent evolution happens when different species solve a common problem in their environment in a similar way. In other words, it makes evolutionary sense for pterosaurs and much later, birds to take to the skies.
Another example of this is that most pterosaurs were covered in fine hairs called pycnofibers, some of which resembled primitive feathers. Were pterosaurs feathered or just hairy? That's a burning hot paleontological debate for another episode.
So far, we've found over 200 species of pterosaur, ranging from the giant Quetzalcoatlus all the way down to the size of a sparrow. Despite finding new species all the time, there are still huge gaps in the pterosaur fossil record.
So far, we know that pterosaurs started evolving around 215 million years ago, starting out small and getting bigger and weirder over time. This, of course, culminated with Quetzalcoatlus, whose outrageous size is at the very core of the debate on its ability to fly.
What the fossils Lawson found in 1975 told us was that Quetzalcoatlus had a massive wingspan of over 10 meters. That is roughly the length of a school bus, or 53 bananas.
But wait, we only have the bones of one wing of the largest example of Quetzalcoatlus. If we don't have a complete skeleton, how do they even know how big they really were? This is when other, smaller, but more complete Quetzalcoatlus individuals from the other described species came into play. Paleontologists use the measurements of more complete fossils to extrapolate just how big the largest Quetzalcoatlus really was. This, however, seems to be open to interpretation. That's why there have been over 50 estimations of the span of its wings in as many years. These range anywhere from 5 to 20 meters.
Even at a whopping final estimate of 10 meters, it kind of feels like Lawson undersold its size when he called it a large pterosaur. When standing on the ground, a Quetzalcoatlus would have been about the height of an adult giraffe.
Despite their huge size, Like today's birds, Quetzalcoatlus had hollow bones that would have meant it weighed just between 100 to 200 kilograms, or about the same as a lion. For context, the heaviest living flying bird is the cory bustard, and it weighs a tenth of what Quetzalcoatlus could have weighed. And even at just 20 kilograms, it looks like it's about to collapse from exhaustion every time it takes flight.
Okay, but could it fly? Let's take a deep dive into the paleontological beef that has been raging for the last half-century. So we have Lawson's initial publication in 1975 claiming that they were flying creatures, but soon after, an engineer called Crawford Greenwald challenged that idea.
Greenwald used modern birds to compare the ratio of their upper arm bones to the relative size of their wings to suggest that Quetzalcoatlus could not have flown. There were simply no modern analogs, no giant flying bird that we can use as a model. And the idea that a 200-kilogram animal could have powered flight seemed pretty far-fetched.
Greenwald did admit in his paper that the structure of this giant pterosaur must have been very different from modern birds. But this challenge would set the stage for further questioning of whether Quetzalcoatlus could fly. Two other papers added fuel to the fire and weight to the idea that this was a non-flying animal.
The first concluded that the ability to fly is restricted by the size and physiology of the creature doing the flying. Their models revealed that the limit was 40 kilograms and a wingspan of 5 meters, and Quetzalcoatlus blows those limits out of the sky. The other one reached a similar conclusion. They estimated that Quetzalcoatlus weighed over 500 kilograms and was clearly way too heavy to fly. The assumption was that the ancestors of Quetzalcoatlus could fly, but by the time this giant appeared, it had lost its ability to fly. Kinda like how the ancestors of ostriches could fly, but ostriches can't.
Paleontologists Mark Witten and Michael Habib got a little bit cheesed over these claims, so they went back to the very scarce fossil material to settle the debate once and for all. Their diss track was titled, "On the Size and Flight Diversity of Giant Pterosaurs, the Use of Birds as Pterosaur Analogs, and Comments on Pterosaur Flightlessness," and basically said that it's silly to use modern birds as a model to figure out if unrelated pterosaurs could fly.
On re-examining the fossils, Witten and Habib discovered that the upper arm bones of pterosaurs like Quetzalcoatlus were twice as strong as they expected. They concluded that Quetzalcoatlus probably took off from all fours, using its strong arms to assist in pushing off the ground.
The idea was that they were so good at push-ups that they could get quite a bit of hang time, and from there, they could glide. I gotta do more push-ups. But it wouldn't be beef-riddled paleontology if that was the end of the story.
Around this time, new models were suggesting Quetzalcoatlus might have been lighter, making its self-powered flight more likely. The wings were also discovered to be more like reinforced sails than like bird wings. That would have given them more structural strength and made them more likely to support their heavy weight. So, once they were airborne, they could glide like a sailplane.
Since then, the consensus has landed on Quetzalcoatlus being able to fly, but there are still some questions yet to be answered.
Like, why did it have such long legs if it could fly? Was it possible that young Quetzalcoatlus could fly, but as they got older, they lost that ability? Why did it live inland if it needed strong air currents to glide? What did it eat anyways? And if it was a predator, how did it catch its prey? And if it flew, how fast could it fly? And how would it even land safely?
These are just some of the fun questions we're trying to answer. And the more fossils we find, the clearer the picture we'll have on the skyworthiness of these giants. Pterosaurs were at the height of their powers when their time on Earth was cut so rudely short by an errant asteroid. But can you imagine what it would be like if these giants were still soaring through the skies? Sully Sullenberger would be in so much trouble. So what should we talk about next?
Imagine being slowly crushed to death by a constrictor so large that it's twice as wide as an average human torso. The muscles of this snake are so ripped that your blood literally stops flowing through your veins as it squeezes tighter still. That last breath you took? It's going to be your last, since it's now wrapped its 15-meter-long form around you. Could this terror be in our future? Let's find out by looking into the past. This is Vasuki Indicus.
We thought we'd already uncovered our planet's largest snake, but paleontology is never short on surprises. Turns out we were so dead wrong, we were practically fossilized. Is this the new longest snake ever to be discovered? Let's dig in. Vasuki Indicus was a giant snake that lived around 47 million years ago, during our current geological era called the Cenozoic, which began after the dinosaurs went extinct 66 million years ago. In 2004, researchers first described these 27 vertebrae as a new species, naming it after Vasuki, a mighty serpent king from Hindu mythology. That's despite having found the bones way back in 2005. In paleontology, there's no need to work quickly since the fossils they find aren't exactly going anywhere.
Given the size of the bones, they were able to determine that the living Vasuki snake would have likely been between 10.9 and 15.2 meters long and weighed up to a ton.
For some perspective on just how big that is, imagine 2 to 3 giraffes stacked on top of each other.
These 27 vertebrae of a single individual may not seem like much, but they can tell us a lot about these extinct reptiles. First of all, some of the bones were actually laying in the same position they would have been inside of the snake.
The vertebrae themselves can also tell us how this snake would have looked from the outside.
The fossils show how the ribs would have been attached, telling us that the snake had a broad and cylindrical body and would have probably looked like a large python.
Bones can also tell us a lot about how the animal would have lived.
Because of the shape of these backbones, scientists have hypothesized that it was not a marine snake, since they have different bone structure from what was found. Instead, researchers believe that Vasuki would have lived in marshy swamps, leading a terrestrial or semi-aquatic life.
Vasuki was a constrictor-type snake and would likely not have been venomous. Instead, it would have wrapped itself around its prey and squeezed it to death.
While we don't know for sure what Vasuki ate, considering its size, it probably wasn't an active forager, and would have been an ambush predator like today's pythons and anacondas. Based on the type of prey that we know would have existed at the time in that region, researchers can guess that it might have eaten crocodilians.
In addition to crocodilians, paleontologists have found a wealth of flora and fauna in the same dig site, known as the Nereti Formation.
This includes turtles, fish, and even 2 primitive whale species. There are so many marine animals because this would have been a coastal region at the time. Vasuki Indicus was just one species of a whole family of extinct snakes called Madtsoiids. The snakes that made up this family ranged in size, from enormous, like Vasuki Indicus, down to small. The Madtsoiidae snake family appeared around 90 million years ago, but only went extinct about 12,000 years ago.
The paleontologists studying it have determined that Vasuki Indicus was probably slow-moving, but just because it's slow doesn't mean it didn't get around.
While Vasuki evolved in what we now call India, other close members of its snake family spread to what we now call North Africa and southern Eurasia, after the Indian subcontinent smacked into Eurasia about 50 million years ago, and would have made the temperature a balmy 28 degrees Celsius.
These warm temperatures are most likely the reason that Vasuki Indicus and other Madtsoiid snakes were able to get so large in these Middle Eocene tropical zones.
That's because snakes are ectothermic, meaning that they get their body heat from external sources. In order to get as large as Vasuki once was, the ambient temperature would have had to have been very warm. While the direct correlation between environmental temperature and body size has proven to be nuanced, one study set out to determine how temperature impacts snake development. In this study, 3 different enclosures of varying temperatures were created for hatchling tiger snakes. The colder environment snakes had to bask longer to maintain the same internal temperature as the others. And indeed, the colder snakes were smaller. But why would colder temperatures have such an impact on snake size? The researchers had a few theories to explain this phenomenon. One simple explanation could be that smaller snakes, with less body to heat, have an easier time maintaining their body temperature than larger ones. Another theory suggests that the need to expend more energy to find places to bask might explain why they have less energy to grow. Or that digestion is in fact more efficient in warmer conditions, so those in warm climates can better process the energy of what they eat. Whatever the reason, those temperatures sure seemed to help Vasuki become the biggest around. It's actually quite similar in size to the now runner-up in the snake size competition, Titanoboa. Titanoboa also lived in a time that was particularly hot, albeit longer ago. They lived around 65 to 55 million years ago, in present-day Colombia. Because we know about the relationship between size and ambient temperature, the discovery of Titanoboa actually helped scientists gain a greater understanding of the environment and climate in which it lived. One study suggests that Titanoboa not only spent more time growing than its ancestors, but was also growing faster, which would explain why the snake was able to get so big. They concluded that the temperature would have needed to be at least 30 degrees Celsius to support Titanoboa's growth to those giant dimensions. Plant fossils in the area that resembled today's tropical plants showed that Titanoboa lived in an ancient rainforest, the oldest one ever found in South America, and the foundation on which our current Amazon ecosystem is built. While they were both gigantic snakes, there aren't actually a lot of similarities between Vasuki and Titanoboa. Aside from living in completely different times and places, they didn't even live in similar habitats. Unlike Vasuki Indicus, which was a landlubber that dabbled in swamp life, the evidence we've found suggests that Titanoboa was an aquatic snake. We know this because its fossils are surrounded by lots of aquatic animals. Because of its size, it may have moved awkwardly on land and preferred gliding around in the water like today's anacondas. Their teeth, too, point towards being better suited to nabbing slippery fish, which further supports the hypothesis that Titanoboa was aquatic. They may have actually also eaten crocodilians, so maybe that is indeed one thing that Titanoboa and Vasuki had in common. Unlike Vasuki, of which we've only so far unearthed those 27 vertebrae, Titanoboa has a way more rich fossil record. Around 30 individuals have been found, a large proportion of which were adults, and around 13 meters long. Until we find more Vasuki individuals, we won't know their average size for sure. Maybe this one specimen was just huge, or maybe it was small compared to its supersized siblings. So, if we only have a few handfuls of bones, how is it that we can make inferences about the whole species? It's quite common in paleontology to use a modern analog, or a species that exists today and could be used as a comparison for an extinct species. In the case of Vasuki Indicus, researchers used the living reticulated python as their analog. They do admit themselves, though, that this modern comparison is imperfect, since the Pythonidae and Madtsoidae families aren't necessarily closely related. Sometimes, paleontologists just need to use the best available option to them. In the case of Vasuki, they chose the reticulated python because of its large size and their best guess about how similarly Vasuki hunted. They used the inference about Vasuki's preferred habitat to help them choose the reticulated python, which also lives a semi-aquatic life in swamps, marshes, and lowland forests. The researchers themselves admit in the study that with no living members of the Matsoidae to use as comparisons, all hypotheses should be taken with a grain of salt, at least until we have more specimens. Okay, but what would it really mean if Vasuki was indeed bigger than Titanoboa? Well, that would dethrone Titanoboa from its high position as the largest predator we've ever found on Earth from the time the dinosaurs went extinct 66 million years ago to Megalodon showing up about 23 million years ago. So, as you can see, the stakes are sky high, or snake long, however you want to say it. While we don't yet know what ultimately drove Vasuki Indicus to extinction or when exactly it happened, we can still wonder, would Vasuki be able to survive today? Or better yet, is there a risk I'll someday be squeezed to death by an oversized constrictor? Considering that the average temperature of the Indian region where Vasuki fossils were located is about 32 degrees Celsius today, you would think that it would be warm enough for this large snake to not just survive, but also thrive. The speed at which temperatures are rising today, however, would make it impossible for Vasuki to reach those enormous sizes. So it looks like we'll be safe from giant man-eating snakes for at least a few more millennia.
Nothing under the sea was safe during the Devonian period with this massive armored predator swimming around. This ferocious fish had powerful jaws that could easily turn prey into chum, even its own kind. This fish almost gave the Megalodon a run for its money. This is Dunkleosteus.
Dunkleosteus torelli lived in the Devonian Sea, a large and shallow inland sea that covered much of today's eastern North America.
The Dunkleosteus swam around the Devonian Sea about 100 million years before dinosaurs even existed. In fact, at the time, there were no terrestrial vertebrates at all. The Devonian was one of 6 periods of the larger Paleozoic era, which saw a huge radiation of fish, which is why it's appropriately dubbed the Age of Fishes, or as I like to call it, big ol' fish time.
The toughest of these fishes were the placoderms, a class of large, bony, armored fishes. Dunkleosteus was a genus of placoderm, and with at least 10 different species, it was both the most famous and most varied.
The largest species, Dunkleosteus torelli, which we're focusing on today, reached lengths of 6 meters. That's the size of an orca. Weighing around 1,000 kilograms, Dunkleosteus torelli was among the largest known Devonian animals.
With a mouth over a meter wide and armored plates almost 5 centimeters thick, this fish was a real tank.
Dunkleosteus torelli was first discovered by amateur paleontologist J. Terrell and his son in 1867 on the shale cliffs of Lake Erie in Ohio. In 1930, David Dunkel, a paleontologist at the Cleveland Museum of Natural History, found additional fossils, and so the combo moniker of Dunkleosteus torelli was born.
Terrell dubbed his find the terrible fish. At the time, terrible was used to mean causing terror, and terror-causing this fish certainly was.
Thanks to its bladed, jaws-of-life-like jaws, Dunkleosteus torelli had an extremely powerful bite. It was capable of opening its mouth 45 degrees and could snap its jaws shut with the force of over 7,400 newtons. It takes just about 4,000 newtons of force to break a femur, the strongest bone in the human body.
Their bite was almost twice as powerful as the famous bone-crushing hyena.
It was even stronger than today's lions, black bears, and even spotted hyenas. Only very large alligators and dinosaurs could chomp down harder than a Dunkleosteus.
If they ever do a sequel to the Meg, it should be called the Dunk.
Dunkleosteus didn't have teeth, but rather two blade-like protrusions flanked by self-sharpening jawbones. Not only were these bony plates perfect for slicing and dicing, the simple act of opening and closing its jaws ensured that they stayed sharp as knives.
So basically, the jaws of Dunkleosteus were both killing machines and whetstones in one. With that kind of efficiency, you can call them Swiss Army jaws.
The jaw action of the Dunkleosteus is part of the reason it became the top predator in its environment. Its jaws were not only extremely powerful when slamming shut, but also ridiculously quick to open.
So how do we know how fast it could open and close its jaws if it's been dead for hundreds of millions of years? In the case of Dunkleosteus, researchers used biomechanical modeling to reconstruct how it worked.
Instead of relying on modern relatives to give a comparative understanding of how extinct creatures moved, biomechanics of fossil creatures leans on the laws of physics.
Some things never change, and that certainly applies to the physical laws of ancient fish bites.
Biomechanical modeling is done to make predictions about things that can't be observed, like just how fast a long-extinct fish could open and shut its jaws. This study revealed that Dunkleosteus's jaws opened in about 60 milliseconds, meaning it may have even been taking advantage of the suction power it generated to catch elusive prey, like some modern fish.
The average human blink takes about 100 milliseconds, so it was literally faster than the blink of an eye.
The sheer speed and power of its jaws meant that Dunkleosteus turelli was the apex predator of the seas and was able to eat basically whatever it wanted. Sharks, fish, even the armor of other placoderms would have been no match for those guillotine-like mouth blades.
Fossils of the dunk have been found with scars and wounds from other Dunkleosteus, so members of this ferocious species weren't even safe from their own siblings.
The armor of Dunkleosteus was formed of many interlocking plates, but only covered the head and neck of the fish. Their bodies were either naked or covered in small scales, which would have decayed quickly. This meant that often only the front portions of Dunkleosteus were fossilized, making it harder for us to get the full picture of these enormous fish. Another complicating factor is that the plates would often fall apart when the fish died, making it hard to puzzle them back together. A few fossil examples, however, do exist to show just how the plates fit together when the fish was alive.
So why don't we have giant armored fish today snapping at our legs at the beach?
Scientists believe that two separate events of low ocean oxygen levels during the Devonian were responsible for the extinction of all placoderms, including Dunkleosteus.
Basically, they all suffocated.
One recent study linked this latter mass extinction, called the Hindenburg event, to UV radiation entering through a hole in the ozone layer. Let's just hope we can put the brakes on our own human-caused climate change before we set off another mass extinction event.
What is the last thing you'd expect to trip over in one of the driest places on Earth? How about the bones of possibly the largest whale to ever exist? Early estimates put it at close to 20 meters long and weighing 340 tons. And when I say big, I mean textbook example of gigantism kind of whale bone. That's exactly what happened to researchers in the Ica Desert back in 2013. And this wasn't just any big ol' whale. This species blew our understanding of gigantism completely out of the literal and figurative water, at least for a little while. This is Perucetus colossus. Today we're talking about the Perucetus, a relatively newly discovered giant whale that has been confusing the heck out of paleontologists since they first laid eyes on it. So let's start from the calm before the storm. Peruvian paleontologist Mario Urbina was surveying a rock at the Ica Desert in Peru when he found these very strange fossils. Some scientists even believed that they were likely just weird rocks. The fossils were dated to be from the late Eocene, a time with few true giants, which made things even more confusing. Each of these rocks was over 100 kilograms, which meant that if they were bones, they would belong to an absolutely massive animal. But after years of working on them, chemical analyses showed that they were ancient bones. These massive boulders were vertebrae. And there was a giant buried under the rock-hard soil of the desert. It took the team 10 years to unearth all the fossils. The final haul was 13 vertebrae, 4 ribs, and a partial hip bone. The small hip bone and the club-shaped ribs resembled those of Basilosaurus, another giant whale of its time. This was a brand new species. These bones were 3.5 times heavier than the next biggest whale that had ever been found from that time period. So this was a puzzle, with pieces that wouldn't fit in any other puzzle ever solved. And the paleontologist only had 18 of the roughly 200 bones of this whale. Most importantly, they didn't have a skull, so they weren't even sure what kind of whale it was. But they did have a point of comparison, Syntheocetus peruvianus. This was another whale from the same period, and it had similar bones to Perucetus. The team used Syntheocetus as a model to see what a full-sized Perucetus could weigh, and found that the skeleton alone could be between 5.3 to 7.6 tons. That's about 3 times heavier than a blue whale's skeleton. The math also showed that Perucetus was around 20 meters in length, or about the length of 2 large school buses parked end to end. That's not quite as long as today's blue whales, so while Perucetus didn't win in the length contest, the bones implied that it might just be fighting in the wrong weight category. The team knew that modern whales have about 45 times as much flesh, fat, and organ mass than bone mass. This meant that this whale could weigh up to 340 tons, almost twice that of the blue whale, which currently still holds the title for heaviest ever animal. A big reason for this insanely huge size estimate was that they had super dense bones. They showed evidence of osteosclerosis, which means that the usually porous spaces inside were filled with solid bone. The bone was so hard, in fact, that one of the scientists studying the vertebrae said that it broke the drill on the first attempt to bore inside of it. For a brief little while, we had this vision of a sausage-shaped whale that broke all the rules of biology. Gigantic girth, extremely thick bones, and a tiny little head that somehow would consume enough food to keep up the metabolic needs of a beast this size. And this is where Perucetus gets really interesting, because the story didn't end with the headline. The first estimate made it sound like the blue whale had been dethroned, but the only thing paleontologists actually had were a handful of bones. And they were missing the skull, the tail, the limbs, and despite having vertebrae, they didn't know what the full spine looked like. All the calculations depended on how we imagined the missing parts looked like. But in biology, rules can't really ever be broken, and new teams of researchers found a few problems with the initial calculations. First of all, they pointed out that the ratio of skeleton to soft tissue doesn't stay the same as animals grow. More conservative ratios downsized the whale by over 100 tons. Other animals with super thick bones, like manatees, have a much lower ratio of soft tissue than whales. So, using their new 3D models, they calculated that it would weigh about 65 tons if it was 17 meters long, or about 100 tons if it actually grew to 20 meters. Still a giant, but not as heavy or as long as a blue whale. This might seem like just normal science squabbling, but shots were officially fired when one of the researchers went as far as saying that these estimates would make Perucetus impossibly dense. I don't know what he sounds like. If you spent any time learning about extinct animals, you'll know that paleontologists love to roast each other publicly. As we mentioned earlier, manatees and their cousins, the dugongs, have these kinds of bones. Sirenians have evolved such dense bones to counteract the natural buoyancy of all that blubber and keep them underwater close to the sea floor to feed on aquatic plants. Perucetus likely had a similar lifestyle, except it was almost surely a carnivore, because as far as we know, there hasn't been a single vegetarian whale in the whole history of cetaceans. Then in 2025, another heavy blow to the former heavyweight champion. The ancient whale that was used to find its size was argued to be wrong. Ay, Perucetus can't catch a break, eh? Instead of using Syntheocetus, researchers argued that they were closer to Pachycetus. That meant that they had fewer vertebrae, meaning that they were shorter than they originally thought, and their skeletal weight was reassessed to be about 6 tons. They also argued that calculations based on side views overestimate mass, so they also used top-down calculations to come up with their new weight estimate, about 40 tons. That's it. They wouldn't even crack the top 5 heaviest whales alive today. The blue whale, the fin whale, the bowhead whale, and the 3 species of right whale all weigh over 50 tons. So our friend the Perucetus is no longer a giant among giants. What they are, though, is the platonic ideal of being big-boned. Even at 6 tons, their skeleton is 2 to 3 times heavier than a blue whale's. So there's still a lot to marvel about this enigmatic chubster. For example, outside of arguing about their weight, what were they like? Shouldn't we be asking the important questions? Back in the Eocene, when Perucetus was bobbing around, the Ica Desert where it was found was a shallow marine environment. The buoyancy control that it would have achieved with these dense bones would have likely helped it feed in shallow coastal waters, just like a manatee. Unlike a manatee, though, Perucetus was likely carnivorous, like all other whales that we know of. But since we don't have a skull, we can only speculate about what it ate and how. Some researchers suggest that Perucetus ate bottom-dwelling animals and coastal fish, or that it scavenged on carcasses. Or it could have chased prey like giant squid or sharks, just like modern-day sperm whales, and likely Basilosaurus. But the fact of the matter is, we simply don't know, and we'll never know for sure until we find a skull. Whatever it ate, it would have had to eat a lot to maintain that huge body size, considering that a blue whale can pack away 16 tons of krill per day. That's on average about 1 million calories on the daily for the blue whale to maintain its round and perfect figure. On a general note, it's easy to understand why the expectations of Perucetus would be so high. The Peruvian desert was awash with the fossils of highly fascinating and record-setting creatures, like the freaky walrus-looking dolphin Odobenocetops peruvianus, or Inkiyaku paracasensis, a giant Eocene penguin species which was just slightly shorter than me, and Thalassocnus natans, the only known marine sloth to have ever lived. In one fossil-rich region of Peru alone, called Cerro Colorado, over 300 fossilized marine vertebrates have been found, with over 80% of them belonging to cetaceans. So Perucetus had some big shoes to fill. Even before the discovery of Perucetus, there were a couple of super famous whales found in the Peruvian desert. One extinct sperm whale, which we've already covered in detail in another video, was called Livyatan melvilli, and it was about the size of a regular sperm whale. The big difference here is that it had the largest non-tusk teeth ever discovered. Like, ever. Teeth as long as a carving knife and just as deadly. Then there was Paragocetus pacificus, the 43-million-year-old whale ancestor that still had 4 limbs and webbed feet. It was dubbed the walking whale, and it was capable of leading a double life on land and in the water. It definitely didn't look like a whale, but more like a beaver or an otter. Whales are incredible examples of evolution that we can see with every newly discovered specimen. But that's why Perucetus, while not setting any records other than heaviest mammalian skeleton, is so important. Its discovery proves to us that whales started evolving into the giants we know today a lot longer ago than we initially thought. Until unearthing Perucetus, we believed that whales started evolving into their gigantic selves within the last 5 to 7 million years. And here is Perucetus, 39 million years ago, blowing that out of the water and making us question everything we thought we knew about whale evolution. It also gave us a new type of whale, one built like a tank, shaped like a manatee, and with the face of an ancient whale back when their heads resembled land predators a bit more. TBD on when we find a skull, though. What other fossil giants are there sleeping under rocks, just waiting for a keen eye to notice that their bones are more than just rocks? These are some of the largest superorganisms on Earth, but also some of the least studied. They burn your skin and turn to goo if you try to grab them. It's a disappearing act that tells us something amazing about these deep-sea alien-looking creatures. They're not a single animal, but a chain of clones working together. How does that work? And what questions does it ask about what it even means to be an individual? This is the fascinating world of Siphonophores. Today, we're taking a deep look at one of the weirdest superorganisms on Earth, the Siphonophores. From afar, some species look like gigantic, segmented deepwater jellyworms. From up close, they're a series of conjoined clones, all working together, but many with different jobs. Sounds confusing? It is. So let's start from the beginning. They're cnidarians, distantly related to jellyfish, which is why they have such a ghostly complexion. This massive sea monster lookalike is Apolemia uvaria, sometimes incorrectly called the stringed jellyfish, or more accurately, the long, stringy, stingy thingy. It's the largest siphonophore ever recorded at over 40 meters, or about 150 feet. It's longer than a blue whale, and if it was an animal, it would be the longest animal on Earth. But it isn't. This is a group of clones attached to each other. Individually, they look like this. They're called zooids, and they're about the size of a grain of rice. That means that a single siphonophore can have tens of thousands of individuals joined together to make a biological mecha predator. The most amazing thing about them is that they start as a single individual, and the way that they grow blurs the line between individual and organism. Like you, me, and most other animals, siphonophores start as a fertilized egg that grows into a mature body. This is called the founding member of the colony. As it gets bigger, a stem grows. This is the infrastructure that will connect all of the clones. The stem has specific spots called growth areas. Here, clones of the founding members start to grow, but they no longer look like the original zooids. They will grow in different shapes depending on their job. Some will be meant for swimming, some for catching prey and digesting it, some for sexual reproduction, and some for floating. You put together enough of these zooids and you get yourself a ginormous colony. You might be wondering, if they're attached to each other and they have the same DNA, why are they considered individual animals? Each of them has its own nervous, vascular, and digestive systems. If you separate them from each other, they'll survive for a bit, but not for long. It's an amazing feat of organization. The different types of zooids appear always in the same order, making it a truly harmonious structure. Older zooids will be at the back and younger ones at the front. They swim, hunt, and reproduce together without a brain to coordinate their actions. Each zooid has a specific function and it worries basically only about itself, but sharing nutrients and energy through the stem. This modular system allows them to create amazing superorganisms, like the apolemia we saw earlier. This was filmed in Western Australia by an underwater drone called Sebastian. It was filmed at 630 meters deep, and it was organized in an eerie spiral, giving me some Junji Ito vibes. Some smaller members of these species have been observed at depths of up to 1,000 meters, and there's likely more species yet to be discovered at the depths of the ocean. The tentacles can be over 5 meters long, about the same length as a car, even though they look tiny in this video. Each of them is armed with microscopic needles full of venom. If prey touches it, it gets paralyzed and eaten. Yep, touching long, stringy, stingy thingies hurts a whole lot, but we'll get into the Siphonophores you should worry about in a little bit. For now, let's keep looking at some of the most amazing species in the world, like Forxalia edwardsii. It doesn't have a common name, but can I suggest the boa scarf siphonophore? This beautiful species is usually around 1 to 3 meters long, but this particular superorganism was almost 5 meters long. At the front, you can see a little balloon, followed by a series of inflatable chambers that suck in and expel water to give it jet propulsion. The rest of the body is full of feeding and reproductive zooids. This siphonophore is so huge that you can even get close and see all the small animals get caught in their feeding zooids in real time. It looks beautiful and harmonious. But for these little invertebrates, this is not a scarf, but a noose. The feeding zooids will dissolve them, absorb them, and send the nutrients to the other zooids throughout the stem. And how about a siphonophore with a stem so short, but with such a high density of zooids that it basically looks like a jellyfish pom-pom? This is a deep-sea dandelion, a strange siphonophore that feels more at home sticking to the bottom of the ocean rather than swimming around like most of its cousins. This one was seen at a depth of 2,500 meters, or about 5 CN towers deep. These mysterious balls of zooids are very difficult to study, so we're not exactly sure what the little balls it seems to be shooting out are. Regardless of what they are, it's amazing to see a creature living peacefully in an environment that would be absolutely unsurvivable to us. These are just some of the hundreds of siphonophore species. There's a huge diversity both in looks and behaviors, as they have adapted to life at different depths, temperatures, and hunting different prey. Some of the coolest research we're seeing right now is how they evolved to catch different types of prey. As you can imagine by the sheer amount of species, sizes, habitats, and shapes siphonophores have, they eat different kinds of prey and have adapted their hunting tools to be as deadly as possible to their main prey. These tools are on the sides of the feeding tentacles. They're called tentillas and are basically bags full of venomous needles. When an animal gets stuck in the sticky tentacles of the siphonophore, the tentacle moves it towards the tentilla, where it's injected with venom. Of course, it's hard for them to be selective about what gets digested, so they often eat their own tentacles along with their prey. It's like if you were eating an ice cream, but the ice cream was glued to your hand, so you had to eat your hand too. It works for them because they have thousands of tentacles, but don't try that at home. Fish-eating siphonophores have thick tentacles and long nematocysts to subdue muscular prey. Those who eat crustaceans, like shrimp, have long tentacles that wrap around their prey to inject in the soft tissue at their joints. Siphonophores who eat tiny crustaceans have super sticky tentacles to catch fast-moving prey. And those that eat a little bit of everything have a combination of these features. So what is the siphonophore most likely to sting us? That is, of course, one that likes the same food as we do and lives close to us. It's also one of the prettiest creatures at the beach. the Portuguese manowar. They might look like glass sculptures with giant satin frills, something that would make a very pretty chandelier. In some cases, these frills, which are really their feeding tentacles, can be 30 meters long, about as long as a blue whale. But all that long beauty is just living toxic fishing net. Portuguese manowar are specialized in small fish, and their tentilla are designed to pierce flesh. Sometimes they float around together in groups of thousands of siphonophores, and wherever there's warm water and large schools of fish, you can be sure there's manowar. As of the release of this episode, there are warnings in the UK and India because of the high number of these cute venomous creatures. It's a big enough concern that they're being called floating terrors in the news. A fleet of manowar can take out an entire school of fish, and if you happen to swim among their thousands of tentacles, you will be in immediate pain, possibly have a severe allergic reaction, and in some cases, even cardiac arrest. So please, stay away from these cute little bags of poison. Even when they're dead, they can still sting you. But if you do get stung, the best way to deal with it is hot water. No need for vinegar or urine, like it's sometimes advised by locals. They're just going to make you stinky, but that won't help you dull the pain. The hot water breaks down some of the toxins and deactivates any venom needles that haven't deposited their venom. There's so much to learn about these fantastic creatures. So we asked possibly the #1 expert on siphonophores to tell us how we're learning so much about them, and the problems with trying to study a gooey deep-water invertebrate.
My name is Casey Dunn. I'm a professor in the Department of Ecology and Evolutionary Biology at Yale University. And I'm also the curator of invertebrate zoology at the Yale Peabody Museum. So when most people think of the ocean, they think of the coast and the waves. And there's siphonophores out there, but they get all chewed up and torn up in the waves, and then you don't see them, except maybe the Portuguese man of war, which is really amazing. It does wash up on beaches. Most siphonophores don't. So what this means is that you have to get out into the open ocean and then collect them. And there's a few ways to collect them. Even nets tend to damage them. So my favorite way to collect siphonophores is to go way offshore, 100 or more miles or something in a boat, and then jump over the side of the boat and then snorkel or scuba dive. Even though the ocean's very deep, we're not going to the bottom. We're just swimming around in that top layer of water with a bag of jars. And you just can develop techniques to get the animals to swim into the jars. And then you bring the siphonophores onto the boat. And then we have to get them back to the lab.
If you're not careful, they'll break apart, and your research is done. This fragility, combined with venom, is one of the reasons that they have fascinated us for years. You might have even interacted with them without even knowing you were in the presence of an underwater alien.
For, more than 100 years, we've been learning so much about the ocean by going out on these research ships, throwing nets over the side, pulling the nets through the water, and then bringing those nets back up to see what animals and plants and things that the algae are in them. And this has been so important. It's told us, so much about fish and crustaceans and things that are out there. But if you're on a ship and they bring up this net, the first thing that is done with that net when it lands on the deck of the ship is they get a hose and they spray off the net because it's slimy, right? Because it's been down deep. That slime is the siphonophores and the other animals. They're so fragile, they just kind of turn to goo.
And the research is ongoing. As new technologies are developed, we're not only getting more answers about siphonophores, but also more questions are being raised every day.
One thing I love working about siphonophores is we get to ask these really exciting questions with the latest tools, like what cells are present and how are those cells interacting and how does the genome coordinate that. And we get to do that work, which uses, tools that didn't even exist 5 or 10 years ago sometimes. At the same time, when we're out there watching the animals and then collecting them and looking at them, we're doing exactly what people did 250 years ago, which is just observing biological diversity. And I love that I get to do all of those things, right? It's not that because we can sequence genomes, we don't need like microscopes or to just sit with a notebook and take notes on what the animal is doing. We actually need to do all of those things. Like it's not that new technology made old methods obsolete. It's that new technology adds additional questions that we can ask in addition to the old questions that really, might involve just sitting and watching, quietly with the animal and being surprised. And sometimes that's when you see the most amazing things because you didn't even expect it.
That is absolutely fascinating. And as Dr. Dunn said, there's still plenty left to be discovered. All we need is some underwater drones, lots of care, and a keen eye. And lots of protective gear. If you've ever been to a pet store, you might have seen tiny hermit crabs. They're cute, shy, and live in adorable enclosures. But not every hermit crab is that cute. In faraway, remote islands lives a hermit crab so large that even Charles Darwin called it monstrous. This is the coconut crab. Coconut crabs, or robber crabs, get a bad reputation because they're humongous, they have gigantic claws, and they've been seen eating birds and kittens. But if you get past all that, they're actually amazing creatures. Coconut crabs are massive. They can have a leg span of over 1 meter and weigh over 4 kilograms. They're the largest land invertebrate on Earth, and they might have actually reached the current physiological size limit for arthropods. Back in the day, there used to be larger land arthropods, such as the fearsome Arthropleura, which grew to be 2.5 meters long. But as oxygen levels in the air dropped, their large bodies became unsustainable, as they're not as good at absorbing oxygen as vertebrates. Coconut crabs are the biggest land arthropods that we have, but if you want to see them, you might have to travel far. They're found on islands in the South Pacific and the Indian Ocean, with large populations living on Christmas Island and the Cook Islands. Their distribution aligns nicely with the distribution of the coconut palm, even though coconuts aren't their only food source. They are surprisingly great climbers and often climb the palm trees to grab the coconuts. When possible, they prefer to eat fleshy fruit and nuts. Some of those fruits, including the sea mango, have toxins that get sequestered in the crab's bodies and make the crabs poisonous to humans. Their asymmetrical claws are among the largest in the animal kingdom, and for some reason, their left is always larger than the right. South claws represent. Coconut crabs have the strongest claw grip in the animal kingdom at 1,500 newtons. They're helpful for self-defense, hunting, and for opening coconuts. To do this, they pull away the outer fibers in a process that might take days. Then, they pierce holes through the eyes of the coconut with their thin and pointy legs. This makes the coconut easier to break to access the meat. Coconuts are so important to them that in areas without coconuts, they're about half the size of coconut crabs from areas that have coconuts. Though mostly vegetarian, coconut crabs will eat anything they can get their claws on. Carrion, rats, birds, and other live animals are consumed when they're available. For mid-sized coconut crabs, their only predators are humans and larger coconut crabs. In one particularly gruesome case, a coconut crab was observed eating a red-footed booby. The crab was observed climbing a tree in the middle of the night. It approached a sleeping red-footed booby and grabbed it by the wing, breaking its bone. This caused the bird to fall to the ground. The crab followed it and grabbed the other wing, also breaking it. The smell of blood attracted 20 other coconut crabs, which proceeded to have booby for dinner.
There's a morbid theory that the reason why Amelia Earhart was never found was because coconut crabs may have dragged her into their burrows and eaten her.
Their sense of smell on land is very advanced compared to other crustaceans, and they have convergently evolved an olfactory system similar to insects, with antennae full of chemoreceptors.
Their antennae help them find food, but also help them find potential Valentine's Day dates, which for them is between May and September.
Males deposit a spermatophore on the abdomen of the female. She uses this to fertilize her egg cases, which she carries externally. When they're ready to hatch, she goes to the water and releases them when the tide is high. The babies live as plankton for about a month, fully dependent on ocean currents for movement. When they're a little older, they go to the bottom and use abandoned sea snail shells for protection. Then, within the first year of their life, they go to land and lose the ability to breathe underwater.
If you find a coconut crab, do not throw it into the water. Just give it a good claw shake and send it on its way. I'm kidding, do not touch their claws.
They will continue growing for decades. We're still not sure when they reach their maximum size, but it's believed to be at least 40 years of age, with some scientists claiming that they could grow until they're about 120 years old.
Like all crustaceans, coconut crabs molt as they grow.
They need to shed their old exoskeleton and grow a new larger one. The new exoskeleton is initially very soft, which makes them very vulnerable for a few weeks after molting.
These pinchy boys molt every year.
To avoid harm, they dig a burrow to shed their old exoskeleton, then they eat it to recoup nutrients and wait for the new one to harden.
I guess they really hate birthdays.
Unfortunately, it's getting increasingly hard to find huge coconut crabs. They got this big because they had no natural predators on their islands. But humans and the animals they bring, such as dogs and pigs, have caused a rapid decline in their populations. They're now extinct in part of their historical range, such as Madagascar and mainland Australia.
Hopefully, as we learn more about them, we'll be able to protect them better. But until then, I guess we'll have to keep letting them eat kittens and birds as their populations recover. So what should we talk about next? Please let me know in the comments and be sure to subscribe for new episodes of Animalogic every week. Thanks for watching. See ya!
The greatest animal on land. The African elephant. These beauties have moved from the African savanna to Southern California to teach us about their biology. This knowledge is being used to help save wild elephants. What we learn here at Elephant Valley might change how we see elephants forever. This is the elephant of the future.
Hi, I'm Danielle Dufault, and you're watching Animalogic.
When thinking of elephant research, sunny Southern California might not be the first place that comes to mind. But deep within its picturesque landscapes, there's a place that's leading the pack when it comes to elephant welfare. This is the San Diego Safari Park. Recently, we had the chance to visit and get up close with their elephants and the people who care for them, and the scientists who are using the latest technological tools to learn about elephants and use that knowledge to support conservation efforts. But before we really get into it, let's start with why they're doing it. Elephants are some of the smartest, cutest, and most charismatic animals in the world. They're the largest land animals on Earth and have been part of human life since its beginnings. It's high praise, and it's not even a little bit surprising to hear about how amazing elephants are. Elephants are quite simply undeniable, and they're not only important to us, but also to all animals in their ecosystem. Elephants maintain savannas by breaking down branches, thorny bushes, and old trees. This keeps the grasslands from getting overgrown. This keeps the land optimal for grazing animals, which in turn helps the predators that rely on those herbivores to survive. When they dig for water, they create watering holes that are used by other animals. And as they walk vast distances, they spread seeds through their nutrient-rich dung. Their dung is processed by animals like dung beetles, which spread it out even further and fertilize the soil. At a social level, they live in complex matriarchies with a leader in charge of navigating the savanna, finding food, and leading migrations. They communicate with each other through a combination of sounds, low-frequency rumblings, and body language. When a member of the herd dies, the other members seem to grieve and spend time around the remains of their deceased relative and comfort each other. But unfortunately, we humans haven't been as great to elephants as they deserve. Growing human populations have led to increased farmland usage and conflict with elephants. Elephants sometimes walk over the farms while on their migrations in search of food and water. This makes the farmers retaliate. At the same time, the construction of communities, fences, and roads is fragmenting elephant habitats. This makes it harder for them to make their migrations and access food and water, and by splitting up populations, it weakens their genetic diversity. The illegal wildlife trade continues to be a problem in large parts of their range. And finally, climate change is causing longer droughts, changing rainfall patterns, and making elephants compete with humans for ever-shrinking pockets of vegetation in Africa. Because of all of these issues, elephants are now an endangered species. Okay.